Hello everyone, I am super excited to have you here. Excited about the topic we will discuss. The two topic we will discuss today is all about the birth of the calculus, Euler, Fermat, and Descartes. Intended learning outcomes. First, discuss the birth of the calculus, Newton and Leibniz. Identify the giants of mathematics in this period and discuss their contributions. What is calculus? Do you have any idea what is calculus? Do you know that calculus is one of the basic or fundamental ideas in the modern mathematics? And calculus is the fundamental idea is to study change by studying instantaneous, which means changes over tiny intervals of time, or immediate happening without any delaying. Do you know that there was two-person who independently claimed to invented and developed the calculus in the late 17th century? And one of them is Isaac Newton. Isaac Newton is a mathematician and cosmologist who was prominent in the 17th century. He's probably best known for formulating the laws of motion and the universal gravitation. One of his many achievements was the invention of the calculus. Newton came to develop the idea of calculus and it is focused on the rate of change. Newton used rates of changes to form the foundation of calculus, and his revised theory was published in 1676. Then the next one is Gottfried Wilhelm Leibniz. Gottfried Wilhelm Leibniz was a German philosopher, mathematician, and a logician who is probably most well known for having invented the differential and integral calculus. Leibniz is independently of Sir Isaac Newton because Leibniz is the father of the calculus, and he did a lot of work on using numbers to help describe nature and motion. He developed the present-day notation for the differential and integral calculus, but they are both independently developing the basic of calculus. Next is the development of calculus. There was two types of calculus, which is the differential calculus and the integral calculus. First is the differential calculus. It is rate of change problems. And the second one is integral calculus, which is area under a curve. Both concepts involve ideas. We can do something infinitely many times and get a finite answer. That is usual. Involve things that are infinitely small or are infinitely close together. If we are going to learn calculus, we are going to understand the differentiation. So, to introduce this concept, let's examine a particular problem in a tangent line. Finding the equation of a tangent line. So, before that, what is differential? Differential or differentiation is a branch of mathematics concerned with the determination, properties, and application of derivatives and differentials. So, tangent line. The blue one in the picture is, red rather. Red, the color red line of that picture, that is a tangent line. And the second line or the second point, the 2 points on that blue lines, that is a second line. So tangent line is one of the touches a curve at a point without crossing over it. So the red one is a tangent line. And the second line is one of the intersect 2 points in a line. Basta 2 points gani siya. Bisag any color pa na siya diha or but nga na siya color, basta any color pa na siya diha, basta 2 points, that is secant line. Pero 1 point ra gani siya nya, pa straight siya, 1 point ra ang nakabutang diha sa picture, that is a tangent line. Next, finding the equation of a tangent line. Want to find the equation of the line that is tangent to a curve at some point with the word tangent. We mean that the lines has precisely one point in common with this section of the curve, so there can be only one tangent line as of a slope or any bigger or smaller. It would be necessary all intersect the point of second point. Say the curve we're looking at y equals x squared. It is the basic parabola. So let's choose the point of this curve 1, 1. We know is the point is on the curve because y equals 1 squared is equal to 1. So what is the equation of the tangent line at this point? Y equals, if we will recall the algebra, we know that to get the equation of the line is in slope intercept form, we either need 2 points or 1 point plus slope. But we don't have that information because we have only 1 point. The slope of intercept form is y equals mx plus b. Next, any point of the curves must have coordinates x of x squared because the y value is always the square of the x value. The y value is always the square of x value. Remember that slope is rise over run, so that the slope is y2 minus y1 over x2 minus x1. That will be x squared minus 1 over x minus 1. So, if we move the second around, the line changes as does its slope, but this expression will stay the same. Now let's plug in some values for the second point and see what happened to the slope of the line. Slope is equal to x squared minus 1 over x minus 1. So let's start with the x is equal to 2. So the x squared of 2 is 4 minus 1 over 2 minus 1. So we can get 3 over 1 is equal to 3, or a slope of 3 of a second, 1.5. Slope is equal 1.5 squared minus 1 over 1.5 minus 1. So that the s squared of 1.5 is equal to 2.25 minus 1 over 1.5 minus 1. So we can get 1.25 over 0.5 is equal to 2.5. Therefore, the second of the slope is 2.5. Then next is 1.1. So 1.1 squared minus 1 over 1.1 minus 1 is equal to 2.01 or 2.1. So the next is 1.001. Slope is equal to 1.001 squared minus 1 over 1.1, 1.001 rather, squared minus 1 is equal to 2.01, or the second of the slope is 2.001. So that the m approaches to 2. So I have mistake on this part. The x 1.001. So the over of m equals 1.001 squared minus 1 over 1.001. There is no squared. So wala ni siya squared. 1.001 na ni siya minus 1 is equal to 2.001. So the m is equal to 2, and the slope of the tangent line is must be equal to 2, because if the slope of the tangent line is equal to 2, we do some algebra, and we will plug in an algebra by plug in coordinates of the points as well as the slope in the equation of the line. So if you remember the formula, which is the y equals mx plus b. So the slope of the tangent line is equal to 2. So the y is equal to 1 equals 2. 1, 2 of 1 plus b. b is equal to negative 1. Intercept must be negative 1. Therefore, the equation of this tangent line is y equals 2x minus 1. In finding the slope in this tangent line, we have performed differentiation. We have discovered about the range of change. So next is the integration. What is the integration? Integration is used to find the volume, area, and the central values of many things. So integration helps in finding the antiderivatives of a function and finding area of a curve. So integration is one of the two main concepts of maths, and the integral assigns a number to the function. Integration is the process of finding the antiderivative of a function. It is a similar way to add the slices to make it whole. The integration is the inverse process of differentiation. So there are two different types of integrals, are definite integral and the indefinite integral. So the first is the definite integral. Definite integral is an integral that contains the upper and lower limits, then it is a definite integral. On a real line is a restricted to lie. Riemann integral is the other name of the definite integral. Next one is the indefinite integral. Indefinite integrals are defined without upper and lower limits. So, the fundamental theorem of the calculus links the concept of differentiation and the integration of a function. And let's start the second topic about Euler, Fermat, and Descartes, the giant of mathematics. So, first is Leonhard Euler. Leonhard Euler was a Swiss mathematician, physicist, astronomer, geographer, logician, and engineer who founded the studies of graph theory and topology and made pioneering and influential discoveries in many other branches of mathematics, such as analytic number theory, complex analysis, and infinitesimal calculus. So, Euler contributions in mathematics and physics. First is the calculus of variation, including its most well-known result, the Euler-Lagrange equation. Second is only mathematician who have two numbers named first E approximately equal to 0.71828. Second, Euler-Mascheroni constant gamma A approximately 0.57721. The other contributions of Euler is the mathematical notation. So here is the picture of the mathematical meaning of the symbols here in the left side, where e the base of the natural logarithm a constant equal to 2.71828, then I the imaginary unit equal to the square root of -1. Then the f of x, the function of f is applied to the variable or argument of x. Then the sigma, the big letter E that is called the sigma, the sum or total or a set of numbers. Then the A, B, C are constants, such as the sides of a triangle. X, Y, Z are variables or unknown in an equation. Cosine, tangent, cotangent, secant, or cosecant, or in short, it is a SOHCAHTOA, which mean the trigonometric function for sine, cosine, tangent, cotangent, secant, and cosecant. Then the pi, or the symbol of letter R in pi, the ratio of a circle's circumference to its diameter. Then the other Euler's contribution of birth of calculus. So the first is the number theory, and second is the graph theory and topology. So number theory, first is the Euler interest in number theory can be traced to the influence of Christian Goldbach. So Christian Goldbach, he is a friend of Euler. Then next is most of his work is based on Pierre-de-Fermat ideas, because kanang Pierre-de-Fermat si Euler ang ni human sa mga work ni Pierre-de-Fermat, kay kanang na komplikasyon kayo si Pierre-de-Fermat or something na namatay siya, then si Euler ang nitiwas sa mga work ni Pierre-de-Fermat. Mao na kasagaran sa mga work ni Euler kay Pierre-de-Fermat. Bali siya nitiwas sa mga gigama nga mga formulas or mga ideas ni Pierre-de-Fermat. So Euler's pi function and Euler's theorem. Graph theory and topology. Topological graph theory is a branch of graph theory. It studies the embedding of graphs in surfaces, spatial embedding of graphs, and graphs as topological spaces. It also studies immersions of graph. Then Euler's formula. Euler's formula either of two important mathematical theorems of Leonhard Euler. The first is topological invariance. See the topology relating number of faces, vertices, and edges of polyhedron. It is any polyhedron. It is written f plus b minus e equals to where f is the number of faces, b is the number of vertical, and e is the number of edges. If a polyhedron is having number of faces as f, number of edges as e, and the number of vertices as b, then the relationship f plus v equals to e plus 2 is known as Euler's formula. So this is the topological invariance. Topological invariance is relating the number of spaces, vertices, and edges of any polyhedron. So this is the formula. F plus V minus E is equal to 2. So using the formula of topological invariance, find the vertex, edge, and the face of a cube and solve it using the formula of F plus B minus E is equals to 2. So this is the example of the Euler's formula, where the number of faces is 6, the number of vertices 8, and the number of edges is 12. So 6 plus 8 minus 12 is equal to 2. The Euler's formula is always equal to 2. Then the next problem is solve the problem using the Euler's formula of the dodecahedron with a given faces of 8, vertices of 6, and edge of 12. So F is equal to F is equal to 8, then V is equal to 6, then E is equal to 12. Then the formula is F plus B minus E, so that the 8 plus 6 minus 12 is equals to 2. As you observe to the two example, product of the two example is equal to 2 because 2 is the product of any polyhedron shape. So it's always the product of any polyhedron shape. So next is Pierre de Fermat. Pierre de Fermat was a French mathematician who is given credit for early developments that lead to infinitesimal calculus, including his technique and adequacy. So Fermat contribution is he single-handedly founded modern number theory as well as made advancements in areas such as probability theory, infinitesimal calculus, analytic geometry, and optics. Some of his contributions include Fermat numbers and Fermat primes, Fermat's principle, Fermat's title theorem, and Fermat's last theorem. The next is René Descartes was a French philosopher, scientist, and mathematician widely considered a seminal figure in the emergence of modern philosophy and science. He is the father of modern philosophy, implying that they provided the seed for a new philosophy that broke away from the old in important ways. So Descartes' contribution invented analytical geometry and introduced skepticism as an essential part of the scientific method. His most significant achievement was the use of algebra formulas to describe geometric figures which form a branch of mathematics known as analytic geometry.